Design Patterns Revisited in Modern Java. Presented by Venkat Subramaniam.
Thank you. It's a great pleasure to be here. I want to talk about design patterns. And before I get started, let's think a little bit about patterns in general. Well, I think we can all agree that grandma makes the best pie, right? And you've been talking about grandma's pie to all your friends, and they get tired of hearing you, and they tell you, enough talking, you got to make grandma's pie one day. So they get together, decide to come over to your house on Saturday, and you are nervous. You're going to make grandma's pie. So you call grandma and say, Grandma, I'm in trouble. I've got to make the pie that you make all the time. My friends are coming over. Tell me how to make it. And grandma says, oh, it's no big deal. Take some flour, take some sugar. Whoa, slow down. Tell me how much sugar. And she says, oh, about 2, is it teaspoons or tablespoons? What are the best practices? What are the do's and don'ts? You write everything down. You go over twice. And then on that Saturday, you make the pie. How did it turn out to be? Yeah, I can see that from your laughter, right? It was a disaster. And I lost some utensils with it when I tried it. So you meet grandma the next week. You say, Grandma, your pie was a disaster. And she says, why don't we just make pie while we talk? And you watch her make pie. And what does she do? She takes 2 teaspoons of sugar, measures exactly, and puts it right. Now, she's having a good time talking to you. And then she takes some sugar, tosses it in, and he said, whoa, what was that? She says, sugar? How much did you put? Enough. And that's when you realize grandma doesn't use the recipe that you forced her to give her. What I'm getting to is, about 30 years ago, this book known as the Gang of 4 book, the Design Patterns book, was introduced. It was written by these 4 people. You could consider those 4 people as the grandparents of our industry. And in my opinion, probably the worst thing they ever did in their life is to write the damn book. And the minute they did, everybody thought we could do that. And the legend has it that somebody wrote an email to one of the authors saying, I managed to use 23 of the design patterns from your book. I just couldn't find a way to use one of them. Can you help me? Well, unfortunately, that's not a good idea. And what I find often is, design pattern is a terrible tool for design, in my opinion. I've never really created a design using design patterns, honestly. I think design patterns are a fantastic communication tool than a design tool. So my recommendation to you is when you wake up in the morning, if the very first thought in your mind is, I wonder what design pattern I can use today, call your boss and tell them you're very sick that day. Don't bother going to work. Now that I motivated you so much about design patterns, let's talk about design patterns. So design patterns to me are a great communication tool. So I take a problem, I think about a problem, I start devising it. I had a developer come over one day and said, I'm trying to use this pattern, not exactly sure how to do so. Can you help me? I said, sure, I'd be happy to. Let's talk about what you're trying to do. What's your problem? What is the requirement? He explains it to me. We talk about it for a few minutes. We gravitate towards a board. We start drawing a little diagram. And within about 10 minutes, he said, my gosh, this is so simple. I can implement this in 10 minutes. I'm like, well, glad we found an answer. Best wishes programming it. As he was leaving, he turned around and said, but wait a minute. You discussed the problem. We arrived at a solution. We got a design on hand. But I came you asking how to use that pattern, and you never answered that question to me. And I said, what's your objective? Do you want to solve the problems or use a pattern? He laughed and said, well, I want to solve my problem, thanks, and he walked away. The point, though, is, sure, we can give a name for the pattern of the design we came up with. So I often use patterns to tell my colleagues in what way we are solving the problem, not as a way to sit down and say what pattern to pick from. But having said that, let's talk about a few patterns I think are really useful as a way of communicating our intent and also to maybe avoid some common pitfalls and problems in what we do. Now, we're focusing on Java here specifically, but Java introduced this idea of optional a few years ago. But remember what happens in Java when we write code, something along the lines of, for example, let's say we have something along the lines of a person, get person, and we have some kind of information that you're going to receive to get the person. Now, the problem with this code is, one of the deficiencies in code oftentimes is communicating the intent. Code should communicate the intent when you look at it without having to read the documentation, so that saves us a lot of time and effort. The problem is, this code doesn't quite convey the intent. What happens if there is no person with that particular characteristics that's provided? So we often tend to return null from code. And what happens when you receive a null? Does anyone here enjoy receiving a null as a response? And when you get a null and you call a method on it by mistake, what happens? Now, null is a smell. Null is terrible. Now, if you ever think that null is not a big deal, you should ask one of my friends. Poor gentleman, he's one of the speakers in the conferences. He's a very great guy. But he was at the hotel in the evening after a long day of talking and decided he wants to watch the TV. He turns on the TV, and the TV threw a null pointer exception on him. I mean, I'm telling you, forget about horror movies. When you turn on the TV and there's a null pointer exception on it, he just turned it off, never turned it again. And the point is, nobody really likes null pointers. So how do you communicate the intent that an object may or may not exist? Well, that's exactly the point about returning an optional of a person. So you're conveying the intent here saying, hey, I may or may not have a response. So my recommendation is, if you really, really will always have it, so you can say a person, in this case, get for sure, because you're going to absolutely have it. There's no doubt about it. So if somebody returns a null for this particular function, they deserve to be punished, in my opinion. Because this is supposed to really have the object. So if the object will always exist, return the reference, be done with it. If the object may or may not exist, then use an optional to convey that. And as a result, the receiver can say, well, OK, I got an object reference. Let me verify. If it exists, I will make a use of it. If it doesn't exist, I'll take an alternative route. So optional forces you to really perform that check. Now, having said this, though, while I was explaining how great optional is to convey the intent, there was one developer who came to me and said, but, and I said, what is the question about it? And he said, but what if I return a null from here? And the answer is, you will always have a bigger fool than the foolproofness you ever invent. So the answer is, no, don't do that. So the intent is not to return a null to optional. Obviously, if the object doesn't exist, return an optional of empty. That's what you want to do. But having said that, there are reasons to use optional, but we should never go overboard with things. Because if we forget the intent of why we do things, we introduce unnecessary complexity in code. So for example, there is one thing I would recommend is, for example, let's say we have a void, a set, let's say, person. And in this case, if you say optional of person, and I'm going to say person. And before I go further, I'll say, don't do this. So this is very important because people take pictures, post on Twitter, and then somebody says, this guy's an idiot. So now take a picture if you want to. So don't do this. So the reason you don't want to do this is you really made things worse for the user of your code. Now, imagine the problem with this particular code now. You are calling this function. You're going to say set person, and you're going to then over here say a person, optional of, and then you're going to send the person object, or you're going to say optional of empty, like so. How do you feel about this code from a user point of view? That's very smelly, isn't it? That is quite unnecessary. It's verbose. It's not pleasant at all. So this is actually terrible code, if you will. There is no reason to punish oneself with this. A better option really is, rather than doing this, simply say, set person, and of course a person does exist. So as a return, you can pass that to the function like so. And if you really, really want to do so, simply have a function set person, which doesn't take any arguments. Now, obviously, in this case, you can call the set person, passing the person if you want to, and you can call it again with no information at all, and this is not so terrible at this point, as you can see. So the moral of the story here is, it makes no sense to use optional as a parameter to a function, because as a caller, there is no reason for you to wrap this into an empty and pass it. in a similar way, it really makes little sense to really have fields. So private optional, let's say a string, stuff, this again makes no sense. So essentially why? Because the problem with this code is you really wrapped a stuff into an optional, but it really serves no real benefit except you wasted a piece of memory right there. Rather than holding a reference to a string, you hold a reference to an optional, which in turn holds a reference to a string, and there's more garbage you are creating at this point, but performs no benefit. So at every single point, we have to ask the question, is the code more expressive, and are we benefiting from the concepts we are really using? If we don't think about the benefit we derive, then it becomes ceremony and complexity for no good reason, and that's not a really nice way to write code. So my recommendation is use optional to convey the intent in your code, but don't use optional where it makes really no sense, and using it as a parameter and also to use it as a field really makes no sense. With that said, let's talk a little bit about the next one I want to talk about here, to talk about what I would like to call as a lightweight strategy pattern. Now, when it comes to patterns in general, especially the strategy pattern, we all have done this in the past. So how did you implement strategy pattern in the past? Well, you wrote an interface for the strategy. You wrote a bunch of classes that implement that interface, and the classes were implementing the method, and halfway through you forgot why you were doing all this. That's a lot of ceremony, a lot of code to write. As it turns out, fundamentally, a strategy is a little function. That's what it really is. A strategy is a part of a function, which in turn is a function where you want to alter some behavior. Let's take a look at an example here just to understand what you would do with this. So imagine you're at work and you're writing some code and your colleague insists on writing a function to total up some values, maybe stock prices, maybe other data, whatever the data is. So I'm going to simply, as an example, say total values. Whatever those values may be, we'll call it as numbers. So in this case, I'm going to say a list of integer. We'll call it numbers is equal to, let's go ahead and say list of numbers 1 to 10. We'll start with that really quickly, and I want to total all these values. So how would I implement this particular code to total the values? Maybe you are sitting at work, excuse me, you are talking about having to meet your longtime friends who are coming from out of town. You've been waiting for months to meet them, and that's tonight you're going to be really eager to meet them. And your colleague says, you need to write this function, but your mind is to go to this event, and you're like, fine, I will finish this and go. So you're really eager to get this done, so you say integer values, and what are we going to do here? Let's keep it really straightforward. I say total is equal to 0. I want to return, in this particular case, the value of the totals. We'll say return total from this call. So as you can see, the result is 0 right now. But what I want to do here is to say, let's say I equal to 0. Oh, well, actually, let's just say element coming from the values. Let's keep it really easy. And what do I want to do with these values? I'm going to simply say a total plus equal to the element given to us. So we total those values. So as you finish it and you're getting ready to go to this exciting event, your colleague, the one who annoys you all the time, comes to you and says, oh, but I need one more function. I want to total not just the values, I want to total all the even values as well. And you are looking at your colleague and saying, so you want two ways to do it. You want to total the values, but you want to total the even values as well. And your colleague says, yeah, exactly, I want both of those. And you're thinking about it, how do I implement this function? I don't have time, I want to really leave right now. And then you realize there is a reason why they invented copy and pasting, right? I mean, imagine this. If nobody should ever use copy and pasting, why would they have that as a concept? In fact, it's so cool, they even have a shortcut key on the keyboard, right? Control-C, Control-V, how cool that is. So you realize you can just copy and paste it and get the work done, right? So just highlight it, Control-C on it, and then you just copy it and paste it right there. So easy, isn't it? And then, of course, you can rename this as total even values, obviously, in this case. So we can go back to this and say, here's the even values. And what do we do with this? Oh, very simple. All I have to do is simply say, if the element mod2 is equal to 0, I want to simply total it, otherwise simply ignore it. Well, that was not that bad, isn't it? So now that we wrote it, before you could slip away, your colleague says, but I really need one more function from you. I want to total the odd values now. And you realize copying and pasting a third time is an act of criminal negligence. But nobody is looking, right? Well, the point is, that's not going to be the solution you want to create in the long term. So pretend that this never happened. Let's kind of unroll that for a minute. And your colleague says, I need this function to total the values. I want to be able to total the even values, have that working. So what do? We decide it's time for a strategy. So going back to this code, we can say, hey, I want to total all the values, but there are times when I want to exclude some values. That becomes the strategy. So why not simply use the strategy pattern and pass a function to this function where that other function can give us the strategy? So we can go back to this code and say, I want to bring in a predicate right here, where the predicate is coming from the Java util function, obviously. And I'm going to simply say dot, let's say, a comma, let's say in this case. And in this case, we'll bring in a predicate, which is going to take an integer, and we will call it as a selector. So now that we brought in a predicate, what are we going to do with it? We can simply say, if the selector test of the element is true, then go ahead and total it. Otherwise, simply ignore that particular value. So we can then pass the strategy here, given an element, simply return true. So we did a little bit of refactoring on this particular code. So now we can easily go back to this and say, if element mod2 is equal to 0, then total only the even numbers and not other values. Your colleague now says, I want to total odd values as well. And you can tell them, go back to your desk and do it yourself, because we made the function general enough. So you can generalize the code using the strategy pattern, but lambdas can serve as a function as a result. Because strategies are really functions, you can readily use them to implement a pattern. You don't have to waste your time and effort creating interfaces and classes. So this is one of the things to embrace, is to realize that functions are first-class citizens. We can pass them around, and we can design with these functions, and we don't need to reach for classes all the time when we write the code as well. Now that we talked about using the lambdas for that purpose, some of the age-old patterns can become really effective as the languages evolve as well. And I want to talk about this here with an example of how we can use the factory method pattern, but by way of using interfaces and default methods. So let's understand this with a little example here, if you will. So let's say we have an interface called a person, and the person interface contains a default method called, let's go ahead and say play, which is going to simply perform a play method. Well, to the play method, obviously, I want to say, in this particular case, we'll just keep it really simple. We'll say playing, let's say, with, but I need a pet to play with, isn't it? So I say get pet, and I'm going to play with a pet. So this interface person has a play method, which is default, and we say get play and use that. So there's this tension and often a question among developers, should we use abstract classes, or should we use interfaces with default methods? Well, interfaces have default methods, which means that interfaces can carry some implementation code in them. So the question is, should we use abstract classes, or should we use interfaces with default methods? The golden rule that I try to follow is that interfaces are almost always superior over using abstract base classes. Now, when do you want to use an abstract base class? You want to use an abstract base class when you truly want to share an implementation of a field or a state in general. But that's not something you want to do too often, because that can lead to other problems in design. It's far superior to implement interfaces where you can. But of course, in the past, the problem was interfaces couldn't carry any implementation at all, so the effectiveness of them were a little bit limited. But now interfaces cannot have fields, but they can have methods in them implemented. So that really takes that further into how we can benefit from them. So we can implement something like a factory method really nicely in here. So we could say a pet, for example, get pet, but we can leave that method as an abstract method, as you can see in here. So let's say we have an interface or a class called pet, doesn't really matter. Let's say interface pet, and I want to create maybe two things from here. So we can say we have a class called dog, which implements the pet interface. We also have a cat, let's say a class called cat, which also implements a pet interface. So we got two implementations going here for us. Now what we could do here is we can say we want to create, let's say, a class called a dog lover, and who implements, let's say, in this case, the person interface. So we can say implements person. And what do we do here? We can say public dog get pet, and we can return our friend buddy here. So we can say new dog and return it from the call like so. So we can easily do the dog lover, let's say Dave equal to new dog lover, and we can then say Dave.play, and Dave likes to really play with the pet dog and can be implemented. On the other hand, if I say a cat person, and I say a cat person for a good reason, anybody with a cat as a pet? Does your cat love you? Yeah, that's the problem, right? So there's a very big relationship difference here, isn't it? Dogs are humans' best friends. Cats think they own you. But we still love them, right? We try to at least. But anyway, we have implements in this case, and we have person. And of course, you can implement your public. We can say cat get pet. And of course, you can return your cat, whatever that implementation is going to deserve returning. You could do that as well. So you can say, in this case, cat person dot play as well. And of course, this is a bit of a trivial example here, but nevertheless illustrates the point in this particular case, which is that you can have a very nice way of implementing certain methods in the default methods in the interface. Now, the general principle we often follow is when we implement an abstract base class, we put the methods in the abstract base class, and those methods in turn talk to the field that you would often have in your abstract base classes. To me, that is very limiting. The reason it's limiting is you are trying to force yourselves to an implementation of that field, but I may not know what that implementation is, or I don't want to restrict myself. I may want to have different classes that implement that field differently. There could be a possibility where a class doesn't have the field at all. It might go get the data from a database or get the data from a remote service, so I may not even have a field to represent that property. So the beauty of this approach is your default interfaces, rather, can have default methods where the default methods can carry the implementation, but they can take these properties and they can truly abstract it out. Those properties can be implemented by the derived classes, and the implementation can vary. You may not even have a field if you don't want to have a field, so that gives you quite a bit of flexibility, and you can really enjoy using the factory method, but in combination with default methods as well. That becomes really effective. So with that said, I want to go again to an age-old pattern, but we can do that in a nice, elegant manner. Well, most of us probably have at least read about and heard about decorator pattern, even if we may not have used it extensively. But remember that infamous example of decorator. I apologize to remind you about it, but it helps to set the context. So remember that very infamous example of decorator. What is that? New buffered input stream. Remember that? And then, of course, we say parenthesis new data input stream, a parenthesis new file input stream. Remember seeing this? When you looked at it, what went through your mind? You looked at it and said, what is this pattern again? And they said, this is called the decorator pattern. And then you look up the dictionary in doubt. Does the word decoration mean take something and make it look ugly? Because you're like, my gosh, why would anybody do this? This is a monster in front of you. Why would I want to write a code like that? Well, the word decoration is supposed to make things beautiful, to make things elegant, and none of that seems to be possible with this code. Well, the reason really is it's not the flaw of the pattern, it's the flaw of the implementation. So definitely we don't want to do this. But let's think about what a decorator pattern really is. You know, I like to be fairly informal. I wear usually about a t-shirt. I wear a jeans pant. This is what I do most of the time. I had a client down in Houston, and this particular manager came to me and she said, hey, we're going to meet the C-level people next week. You're going to have to talk to them. We got to convince about a project. Can I schedule a meeting with them on Monday? I said, absolutely. I'll fly in back Sunday night. We'll meet them on Monday. As I was leaving the room, she said, I got a quick question for you. Are you going to dress up yourselves to meet the C-level people, or are you going to just play against this professor in the jeans pant? And I smiled at her and said, I think you know the answer, see you on Monday, and I walked away. On Monday morning, I walked in with my jeans pant to see the C-level people. But she played it really well. She wore a jeans pant as well. And she said, this is the only way I can defend you, so I'm going to dress up just like you so they don't question you. And so the point is, I'm not going to decorate myself unless it's a funeral or a very important wedding for a friend. So of course, if I'm going for a wedding, I'm going to put on a suit, a jacket. I may put on a tie. I may put a few more decorations on me. That's basically a decorator pattern. You take a core object or a core function, but you decorate, you add flavors to it at this point. Well, my mind is a corrupt mind. I think of programming almost all the time. I live in Colorado. We have a lot of outdoors, beautiful place. So I'm always trying to hike up the mountains. But one of the problems, and I'm going to share this with you so you will never, ever be able to go to the outdoor again without thinking about it. So I apologize for this. But when I go to the outdoor, you know, people from all places come and visit, and they have these beautiful cameras. And usually they have a camera, which is the core. And then they are taking a photo of something, and maybe the light conditions are different, or they want to take something from a really good distance or something closer. So what do? They lean over to their back, they take some camera lenses, and they remove their lenses, they put their fancy lenses, and now they have a long lens. You've seen those, right? Well, whenever I see one of those cameras, my corrupt mind, unfortunately, immediately thinks about this as, oh my gosh, that's a decorator pattern. Because what you're seeing here is a core camera, and they keep using the same camera over and over, but they remove their lenses and put new pairs of lenses, and sometimes they can even add multiple lenses to it. That is the decoration aspect of things. Let's see how that's going to work with a little example in here, if you will. So let's say we have a class called the camera. And in this case, I want to start by bringing in a scary java.awt.color for a minute. And now we can say in this particular case, I have a public, let's say, colors over here, a snap function, which takes an input. And let's keep it really trivial for now. All that it's going to do is simply return the given input to the output. So we'll start with that really here. And I'm going to say, in this case, a public, let's say, static print. And what does the print really do? It takes a camera, and we'll call it as a camera right there, and all it's going to do is to simply say output camera.snap, let's say, and let's go ahead and send new color 125, just pass that into that particular function just for a minute. So if I were to go back here and call the print and pass a new camera to it, and all you would be expecting at this particular point is for it to really print the camera out, the color out. That's basically what you see, so no big difference. But what I want to do, though, is I want to start decorating it. So in order to decorate it, I want to put some filters on it. Don't confuse the word filter here with the word filter in Stream API or Lambda expression. A filter as in one that just filters the colors being passed in. So what I want to do here is to go back to this and say, given an input color, I want to take the color and I want to make it brighter. And so we could pass a brighter filter to this particular camera. Or I can simplify this further by simply saying, hey, I'm going to pass a color right there into this camera. and we're going to pass the brighter function on it at this particular point. So we can simply call that as a color double colon brighter, and we can pass that as well really nicely right there. So all I'm doing is passing a filter to this camera, and in a sense, what I'm trying to do is to decorate it. So how do I really manage to do so? In this particular case, we can take a step and say, well, here is a private, let's say, and I'm going to create a function, obviously, in here. So we'll bring in a function at this point. So this function is going to take a color as an input and return a color as an output. So we'll call this as a filter. And again, this word filter as in filter of a camera, not the filter function in Stream API. So then what are we going to do with this particular filter? We can come in here and say, return filter.apply on the input, and we can pass it. Now, obviously, what is the filter we're going to use? Let's write a constructor here for camera, and all I'm going to do here is to say filter is equal to, given an input, return the input, no filter really at all, or I can pass another function right here, and where this function takes a color and returns a color, and we'll call it as a filter. And in this case, the filter we're going to use is going to be the given filter. So we can simply say this is a filter, and we can pass it. So in this particular case, we can see when we first call it, there is no filtering. In the second case, the color is brighter. So we just implement that particular function. Well, good step. So we can not only brighten it, we can also darken it as well. So we can say darker, and you can see the color is darker than the previous color. So we applied two different filters here, as you can see. Well, that's great so far, but you know where I'm going with this. Why would I want to just apply one filter when I can apply multiple filters? So I can say brighter, comma, darker as well, and we can have a series of filters. But I want you to step beyond this example and think about this in more general terms. You may be implementing a function where, an application where you may have to apply a group of filters. Data is flowing in. You may want to cleanse the data. You may want to transform the data. You may want to mask the data. You may want to encrypt the data or decrypt the data. All of those become filter operation. If you have ever developed a Spring Boot application, you have done Spring filters. That same concept you want to implement in your code, where you want to remove and add filters, you want that dynamic behavior. So how do we accomplish this in our code? So let's go back to this code for a minute and say, hey, I've got a filter coming in, but I want to get rid of that constructor for a minute, and I can generalize this constructor by simply receiving a var arg as an argument, and change this to filters now, because it can be one or more filters that can be provided to it. So what I can then do in this particular case is, I can simply say filter is equal to, but what are we going to do here? Well, if I have a filter, I can assign it to an input arrow input, but then I can say for, and in this case, a filter, where that's coming from the filters, if you will. And then we can say a filter is equal to, and one of the nice things about functional programming is not just you can just use lambdas or streams, you have this beautiful concept called function composition. Function composition is you can take one function, you can take another function, and you can compose them to form a bigger function. So this becomes a very powerful idea. So I can say a filter and then, and I can specify a filter to create a composite filter right there. So once we create that, we have created really a collection of filters at this particular point. So essentially, we have filters coming in, and we are saying that filter input is input as the first default filter. And given a filter that comes from the filters collection, we can say a filter that you have already, and then a filter, you can combine it and put it back into that particular filter. Let's fix the error before we move forward. Line 32 is not happy with me, so let's go over there. So in this particular case, I want to bring a color brighter and a color darker right here. So let's see. Oh, of course, a double colon missing right there. Let's fix that. So now you can see how we are able to combine the filters together. So as a result, we simply accomplish this. You could stop here if you really wanted to, but we can go a little further with this. Does anyone remember back in math school, they were teaching some of these things to us, but we'll get back to that in a minute. But notice what we are doing here. We are successfully refining this filter and keep adding to it. If I were to write this code in functional style of programming, anyone wants to take a guess what function we would use here? Using a stream API, what would be used in this case? Anyone? No? So you're taking a collection of data, but you are converting them into a single piece of data. Reduce, that's what you need to see here, right? It's a reduce operation, bingo. So I can say filter right here. So, oops, let's try this again. So I can say, here's a filter, and then what am I going to do with this filter? Well, first of all, let's bring in .stream for a minute. So I can say filter is equal to a stream of, in this case, filters, and you can then say .reduce, and we want to start with an input, and we can say input. And then we can say, in this case, we get a filter. We'll call it as composed, comma, a filter. And we can simply say composed and then a filter. And we can use a reduce function. So again, we could stop it right here if you wanted to. But why stop now once we start really refactoring it and making it more concise? Does anyone remember back in math school, they were trying to teach us, if you were to take a number and add a 0 to it, you get the number back. If you take a number and multiply 1 to it, you get the number back. Those functions had a name for them. Bingo, identity function. You got it. That's exactly what it is. It's an identity function because given the input, you get back the input as an output. So that's a function.identity. So that's basically the identity function right there. Awesome. And now, of course, with that change, we can do one more refactoring while we are at it. We can simply say this is a function double colon. And of course, that's an and then function we are interested in. And so that really becomes a refactored stream, and we can combine them to a decorator as well. Again, we can take this one step at a time, start refactoring. We don't have to make the leap in one shot, but the essence is we are using a combination of concepts in here. The first one is the function composition. We are taking two functions and combining them into forming a bigger function, and that is using the and then function. Then we are creating a pipeline of these functions, and then we're using that pipeline as a decorator, and then we can pass data through them and perform the transformation. So that's basically where we are passing the decorations to it. And then, of course, in our own code, we are taking that into a pipeline. And then that actually is not a single object, but it's a pipeline of objects that we are using. And we are passing the data through it, a very powerful combination, as you can see. So that's basically a use of a decorator pattern. I want to talk about one more pattern, which is one of my favorite patterns in here, which is called the execute around method pattern. But before I talk about this pattern, I want to quickly give an example. I was at a company where they were saying that they were having some problems in production, but nobody could tell me what the problem was. I kept asking people, what's the problem? And nobody would tell me. And finally, one person said, I know what the problem is. The program fails in production, and when we hit this application, we get an error that the service doesn't respond, resource cannot be obtained. And I said, finally, somebody who can answer the question. I said, do you know when this problem happens? And he said, of course, I know exactly when it happens. It happens between 7 and 9 in the morning. I said, whew, that's good. Does it happen every day? He said, no, only Monday through Friday. It doesn't happen on Saturday and Sunday. I'm like, why would something happen on weekdays and not weekends? Well, eventually I found out what the problem was. But the problem was they had a resource of some sort in their code. So we'll call it as a class resource, if you will. And in this case, it contains a constructor of some sort. So we'll say resource. And just for our purpose, I'll say created right there. They also had, in this particular case, they have another function right there, which is an op1, we'll call it as, a resource op1. And all that is doing is simply output, let's say, op1. And to keep it really in all one line, we'll say return this for now. And that's similarly an op2 function they have as well. But in this case, what they did was they create a resource in their code, and of course equal to new resource. And then of course resource.op1 they call, and they call resource.op2. But this resource was using an external resource, like a database. So you have to clean up the database when you don't need it anymore. So God forbid, what did they do? They wrote a public finalize method. And in the finalize method, what they had done is to clean up the resource, and we will use that here just as a purpose. We'll say clean up. But unfortunately, as you know, that Java's garbage collection is automatic but not instantaneous. So when you run the code, what you're going to notice in this particular case is that unfortunately, though, it is going to call the resource, but it's not going to release the resource for us in this particular case. That's one of the biggest problems you're going to run into. The finalize method will not be called automatically for you. So what are we going to do to solve this particular problem? Well, obviously, the finalize method is not helping me. I'll do the corrections on this really as we go. So you can see in this particular case that the finalize method was never called. So what do we do about it? Well, unfortunately, in this case, we want to clean up the resource. So we want finalize to be called, but it doesn't get called. What's the solution? Well, one solution you can think of is to write a close method. So obviously, you can come here and say resource.close, but unfortunately, though, that's not good enough. Why? Because one, you may forget to call the close method. Second, if there was an exception, the close is not going to be called, so you're doomed in two different ways. So this is not great. Well, Java has a concept called ARM. ARM stands for Automatic Resource Management. So what does ARM, or Automatic Resource Management, say? It says you implement, in this case, auto-closable, and now you can come back here, and you can simply say try like so. And in this particular case, you can simply say, hey, resource that you're given, you can call op1 and op2, and when you leave the block of the code, the close will be called automatically. So this seems like an interesting approach to begin with, the automatic resource management. Well, great. This handles the exception properly for you, and that's a good news. But the problem with this is, good news, you don't have to call close. But the problem with this is, what if I forget to call the try after all? I'm a human. I may not realize I need to call the try. So my question to you is, even though we are implementing auto-closable, if you don't use try, you will get a compilation error, correct? No, not at all. Darn it. Okay, you will get a warning that you're not using try. What about that? No, because deep down in your mind, you know this. Never to ever trust a feature with the word management in its name. So it doesn't give you the benefit you need after all, isn't it? So as a result, this is going to depend on you to do the right thing, but I would really like to make it a little bit easier for me to flow along and not say, oops, I forgot. So this is one of the reasons I'm not a fan of this try with resource or ARM. I like to really have a guarantee this is going to be handled. So what am I going to do? Back to square one we started with. So I'm going to go back and make the private close method private. You cannot call it. The user is not calling it, so no big deal. So what am I going to do then? I'm going to then start making the constructor itself private for a minute. So if I make the constructor private, we'll say private. You cannot create an object of this class anymore. So what gives? How do I use it? So now I'm going to say resource.use and take a resource as an argument. Now I can simply say I want to bring in a resource right there, and I want to call the op1 and op2 and exit. Pardon me. This is called, beautifully called, the execute around method pattern. So in other words, you want to execute a piece of code, but around that code, you want to do a pre-op and you want to do a post-op. So this is a very, very common practice we do. You want to implement a certain logic. There's a pre-computation you want to do, begin transaction, for example. There's a post-computation you want to do, a log, commit transactions, a rollback, whatever that could be. So how do I implement this? You can go back to this code and say, I want to bring in a function.consumer for a minute, and I can then say I have a public, let's say, static. We'll call this one as use, which takes a consumer of a resource. We'll call it as a block, if you will. And in this case, we can say resource is equal to new resource. We can, as an author of this class, remember to put the try and finally block properly, or a catch block properly. And in this case, I can say, a finally block. And then within the finally, I can say resource.close and close the resource when I no longer need it, whether there's an exception or not. And then within this, I can say block.accept and pass the resource to it like so. So in this particular case, as you can see, the cleanup is happening automatically when you exit the piece of code. So this is a pattern I've used quite a bit for a while now, where I can take my code I want to implement, but implement a pre-op and a post-op, but then just hang my code right in the middle. So this is also, you may recognize sometimes, like a template pattern, but this can be very powerful in terms of how we can handle this in our code, so that becomes really, really effective for us to use it as well. So with that said, the last thing I want to mention to you here is, and really quickly, this is one of my favorite patterns. This has been used for a long time in other languages that have supported Lambda expressions. I first came across this pattern in a very old book called Smalltalk Best Practices by Ken Beck years ago, and we can use that in languages like Java today very effectively. Well, the last pattern in about 5 minutes I have with me is to quickly mention about one of the newer features in Java, which is the sealed hierarchy. Let me explain this really quickly before showing a code example. Let's say you have a program where people can write plugins for your application. When they write a plugin, you may want them to implement certain interfaces. You may want them to use your interfaces, but you may not want them to implement certain interfaces or inherit from some classes. So the problem is, how do you create a hierarchy of classes where those hierarchies for you to extend, but for others only to use? You don't want others to ever extend from your classes or implement your interfaces. The short answer is that's really hard to do right now. I've got clients who are doing this with a lot of effort, programming effort. It's a code they have to write, the code they have to maintain. Well, the good news is with sealed, you can do this very effectively. So let's take a quick example in the next about 2-3 minutes and see what this really means to us. So I'm going to say a traffic light.java, for example. I say interface, I'll call this as a traffic light right there. And this can be a class or an interface. And I say final class will say red light. And this really implements, in this case, the traffic light. And I also have, let's say, one more, we'll call it as a green light as well. And then finally, we'll say here is a yellow light as well. So we have 3 classes implementing that particular interface. Well, that's great. Let's go back to our code here and say, I want to say traffic light, and we'll say is equal to new red light, and I want to output the traffic light right here, and let's say here's a traffic light I want to display. So that worked really well. But what if, on the other hand, if I were to create a class called broken light, which implements, let's say, the traffic light? Well, maybe you don't want me to extend your classes. This code works, but I don't want it to work. So what do we do to prevent it from working? So we can go back to the traffic light hierarchy and say, this is a sealed interface. So by making it sealed, what you're saying is, I want the hierarchy to be contained to the hierarchy I define. I want my sealed interface to be implemented by my red light, green light, and yellow light, but no other classes in my system. So if I go back to the code right now and try to run the code, I got an error. The error is saying the class, even if I put the word final in it, it says the class is sealed, you cannot inherit from it. So this prevents us from overriding or inheriting from our hierarchy of classes. This This can be really beneficial for you for modeling purposes, where you can create a model of hierarchy and say, this is a closed hierarchy. You're most welcome to use it, but don't go messing around by inheriting from it. And that can be very powerful in terms of design, and that is a pattern I think we'll start using quite a bit more as we move forward. So we talked about a few interesting patterns here in Java that are available for us and we can benefit from. And as the language evolves, we'll be discovering more better uses of patterns as well. But to kind of loop back into what I started with, I'm a big fan of patterns, but as a communication tool, not as a design tool. So I like to really work on the problem first, understand it, and then gravitate towards a reasonable solution. And then as we near towards it, we can put a name to it and say, aha, this is very similar to an abstract factory or a factory method or a prototype pattern or whatever that may be. It becomes a very effective communication tool more than a design tool. I hope this was useful. Thank you so much for being here.